Hi, folks, HPC friends, cloud friends, dinosaur friends, all the friends. Welcome today. I'm Vanessa. I am one of the Flux framework and converged computing developers at Lawrence Livermore National Laboratory. Today, we're going to have some fun. This is a very unofficial, relaxed Flux framework tutorial. After our HPCIC tutorial back in August, we had a request from you that you wanted to see us walk through some of these commands and some of learning about Flux interactively. So that's what we're going to do today. We're still going to start with a little bit of learning so that we don't just jump into a terminal and you're like, I don't know what's going on. Don't worry. So let's first talk a little bit about Flux. Then we're going to move on to a cluster and do some cool stuff with Flux. How does that sound? If it sounds good, keep watching. Let's go. Okay, so let's start out with the basics. What is Flux? When someone's talking about Flux, they're talking about a workload manager. It combines hierarchical job management with graph-based scheduling. Don't worry if you don't know what that means. We are going to talk about it a little bit more. I actually first want to start with some kind of comical questions that I've actually heard people ask over the years. Like, okay, so is Flux real? Are you sure, like, are you absolutely sure that it's not running Slurm under the hood? You know, like the Slurm queen from Futurama, like hiding in there somewhere. Okay, so to address these first two questions, Flux is absolutely real. You can see all of the source code on GitHub. You can bring it up in a container. You can log into clusters and use it. It is very real. I don't know where this question came from. And the question about running Slurm under the hood, there's no Slurm hiding in Flux. I think this might derive from the fact that we have some of the initial Slurm developers on our core Flux team, and also the fact that you can bring up a Slurm allocation and launch Flux under it in user space. So maybe that's where the misconception comes. I just find this visual very funny of like the Slurm queen like hiding in there somewhere. Okay, so for this third question, is anyone using Flux? I want to answer that in two ways. So first, I'm going to show you a really old map. This is from maybe 2020, 2021. These were institutions at the time that were using Flux. Now, this map is old. It is outdated. This number has greatly increased, and I can kind of say this very superficially just based on the number of emails that we get about centers that are wanting to deploy it, wanting help for how to use it. But let me answer this in a little bit different way. So here you're looking at a timeline that we shared during our HPCIC presentation. This is like the history of Flux. So guess what? Flux has been around a long time. The project started in 2012. But let me tell you, all along this timeline, our core Flux team, which is a very small team, have been working very quietly, designing this beautiful technology and basically trying to orient it toward the goals of the laboratory, so Lawrence Livermore National Laboratory, and specific workflows or workloads at the time. And so it wasn't really until a couple of years ago, I would say with some of the converged computing work, that we started to take Flux and actually talk about it out there. So for example, the Flux operator, deploying it in Kubernetes. And it really wasn't until this year when we're deploying Flux as the system level workload manager on El Capitan supercomputer that it's starting to get some attention, some press. So like Flux, it is a project deployed at a national lab by a small team. We do not have advertising. There has not been an incentive or focus to do that. So if you've gotten to this point and you're an HPC person and you're like, gosh, that's funny, I don't know anything about Flux, but I've heard it with these other workload managers. Guess what? The underlying kind of structure of the projects and how they've been run is very different. And I totally understand if you haven't heard of Flux. But I think from this point on, you absolutely will. So hopefully that answers that question a little bit. So what is Flux? It is a workload manager. This means it's going to receive units of work, your scientific simulations, your jobs, your machine learning, and assure that it is planned, assigned, and executed on typically many computers. We in HPC, we have these supercomputer things, in case so we talk about a hierarchical job management because your jobs can be nested, basically launching smaller units of work within one top level of work. So you might launch a batch job that has half of, some topology that's doing a simulation set of work. The other half is using GPU and some set of services. And actually each sub-instance within that larger instance can launch smaller units, kind of all the way down, like very matrixy, like it's very quite cool. Now, we say that we have graph-based scheduling because we do. Our entire set of resources, so compute, storage, GPUs, other devices, network, whatever, are modeled in a graph. And actually, one of the really cool things about Flux is that it's put together in terms of different components. One of the components is the scheduler. This is Fluxion. You can pull Fluxion actually out of Flux. You can use it separate to Flux, and you can model an ice cream store, the graph of an ice cream store. And I've actually done this with several different projects, and I've had a lot of fun using Fluxion. And so if you're someone that likes to be creative and explore things, highly recommend checking out Fluxion. Okay, so where does Flux run? There is like this misconception. Well, actually, this is very fair. You probably think of Flux and you're like, oh, it is one of those HPC workload managers because it is developed at a national lab. Flux does not care where you deploy it. It is a cluster that needs nodes for compute. And this is actually why it was so easy, for example, to deploy in Kubernetes, why it was so easy to spin up with Terraform on AWS, Google Cloud, Azure. Like we have done it in all of these places. And so, yes, it has been developed at a national lab, but no, Flux is not just for high performance computing, and its design is actually very well afforded by more cloud native environments. It's a framework, as I mentioned, because it's many different projects that assemble it to get together into the workload manager known as Flux. Let's talk quickly about a few of those. I don't want to go into too much detail because we want to get to the tutorial, don't we? Yes, we do. So flux-core is the primary components for Flux framework. This is the part that's been under active development since 2012. It includes kind of some core, flux-core has core components. I'm color me surprised. Several core components that can kind of be generally summarized as recursive launch, a small security footprint, and reactive messaging. There's actually much more to it than that. I'm hugely simplifying this, but this is a very high-level talk. So let's talk about these a little bit. What does recursive launch means? Well, what better way to answer this than in poetry? I can run it on a cluster. I can run it alongside Lustre. I can run it in a share. I can run it anywhere. I can run it in a container using Flux is a no-brainer. And by the way, for folks that don't know, we have a pink bird mascot. We call him Flux Bird, the pink bird that knows things. There's many different manifestations of Flux Bird. This is one of them. Actually, one time he manifested as a radish in my dinner, and I ate him. So, but FluxBird is alive and well. Do not worry. Do not worry. Okay, so where could this Flux instance be? We've kind of talked about this too. It could be on a traditional HPC cluster, a system install. It could be in Kubernetes. This is a Flux operator. It could be run under Slurm or a PBS allocation. It can be run on your local machine in a container. Like you want to test Flux, spin up a container, and like you're done. It can also be accessed remotely via an API. So why is it recursive? We talked a little bit about this because an interactive allocation is this independent Flux instance that's running on a subset of parent resources, and you can recursively subdivide them infinitum. And the reason this is really beneficial is because it sort of contrasts to these traditional monolithic resource managers. So for example, if you have something like something that requires high throughput, like submitting jobs, by way of making Flux instances under parent, you can distribute that work, and this means that Flux can get very high throughput sort of off the bat, and other features as well. Small security footprint, this means there is not code that requires running as root. A Flux instance requires a setuid helper that's provided by a project under Flux Security. For only multi-user configurations, you can deploy it in single user space without administrative access. So for the reactive messaging, this is actually very cool. Flux components are primarily single threads that communicate only by exchanging messages through message brokers. And so if you're ever interested and you look at the flux-core source code, this is a really cool design to see. And this is what made me step back and be like, wow, these Flux devs did a really good job at this. And there's really cool things you can do for this. So for example, this year I made an ensemble project basically running a state machine based on responding to events from Flux. I'm not going to go into details here. I'm sure I'll give a talk about it at some point, but it is like super cool. Alrighty, so how do the nodes communicate? Let's say that we have a 9-node cluster here. We have one leader, the lead broker. That is the one in purple. That's situated at the root of the tree that has some kind of design or topology. That is under a tree-based overlay network. We call this a T-bond, or as I like to call it, the T-bone. And the followers basically join the leader. Here is sort of an illustration of that T-bone. I made this graphic years ago, and I'm still probably too proud of it, more proud than I should be. So the Flux scheduler, I kind of alluded to Fluxion a little bit. This is the scheduler component. This is what models our resources as a graph. How does that work? Well, imagine that you have so you have your cluster's resources represented as a graph. That means that there's nodes, or vertices that have edges. Then you have your job spec, and you take your job spec, and so that's represented in B, and you say, okay, hey, scheduler, can you basically take what I need in my job and then match it to the graph based on some match policy C, pruners and filters. And then if there's a match, that basically means that we can, we're able to run the job. It gets scheduled in the queue. Everyone's happy. I'm happy. You're happy. Flux is happy. Anyway, so Flux Security, we talked a little bit about this. This is the component of Flux that does kind of like it's like the component with like the glasses that's like, signed of the correct permission. So it's doing validation, it's doing checking of permission, it's doing signing of payloads. This obviously is a very hardened component because we are a national laboratory. I cannot stress that enough. I'm not a security expert, but I can tell you that a lot of care and attention has gone into this. And when do you need it? Well, you typically will need this in multi-tenancy environments. So if you're running it under another resource manager, or more generally as a single user installation, or like when I'm running it under Kubernetes, you don't need to worry about this quite as much, but it's there if you need it. Alrighty, so guess what? We're stopping here. I could keep going on about like different components and details or whatever, but I don't want to do that. I want to jump right into the tutorial. So let's do that. I'll see you soon.